Hello, my name is Paul Alsip, and I am enrolled in the astronomy class. First of all, thank you for taking the time to watch my video. My video is about the Galilean moons, Europa, Callisto, Io, and Ganymede. Astronomers like to call these moons a mini solar system due to the great diversity that these moons possess. Galileo Galilei discovered these moons in 1610. He is known as being the father of observational astronomy. Other contributions include confirming the phases of Venus and observing sunspots. He is also known for making improvements to telescopes at the time. There is a portrait of Galileo Galilei. Excuse me if I'm messing up the pronunciation. Okay, the first satellite is Callisto. As you can see, this surface of this moon is very cratered. And here is a brief overview of Callisto. You might not know this, but it's the third largest moon in the solar system. Only Ganymede and Titan are larger. Titan is one of Saturn's moons and it has a thick atmosphere. With a diameter of about 4,800 kilometers, Callisto is almost the size of planet Mercury. It is the outermost of the four Galilean satellites. That means Io, Europa, and Ganymede lie closer to Jupiter. Also, Callisto is thought to be the most cratered object in the solar system. Astronomers believe Callisto has a landscape that is over 4 billion years old. Its surface is very old due to the fact that there's hardly been any geologic activity. So if there was a manned mission there, it would be a great place to study very old rocks. Also, unlike Earth, Callisto does not have plate tectonics. Here are some physical characteristics of Callisto. It has an average density of 1.83. Earth, by comparison, has a density of about 5.5. To give you an idea, Callisto is composed of equal parts rocky material and water ice. Obviously, it's not exactly 50, but it's close to maybe say a 55-45 ratio. Also, the rock of Callisto contains ordinary chondrite rock, and this type of rock contains less metallic iron and more iron oxide. Hence, you have a lower density rating. Also, Callisto is a great base for space exploration, NASA believes. It is considered to be the most suitable moon for human exploration of the Jovian system, and below are some reasons why. First of all, Callisto is about 1.8 million kilometers away from Jupiter, thus it's outside its main radiation belts. So human settlers would need much less radiation protection. Also, as mentioned previously, Callisto is geologically stable. Therefore, settlements would not have to protect against damage from volcanic or tectonic activity. Also, Callisto has a large amount of water ice on its surface. And besides, that's an obvious supply of drinking water. Water can be broken down into breathable oxygen for space colonists. And I also wanted to mention that NASA envisioned a possibility that they could launch a mission, say, in 2040 to Callisto. The next Galilean satellite is Io. Astronomers like to call this a world turned inside out. As you can see, to me, it looks like a Mexican pizza almost. And here is a brief overview of Io. It has a diameter of 3,620 kilometers. and it makes it the fourth biggest moon in the solar system. At a distance of only 422,000 kilometers away from Jupiter, Io is the innermost of the Jovian satellites. And an astonishing discovery occurred back in 1979. Voyager 1 discovered active volcanism on Io. Obviously, this was a stunning find to NASA scientists at the time. Here is an artist's portrait of volcanoes occurring on the surface of Io. You would not want to be there. Here are some physical characteristics of Io. As you can see, it's more dense than Callisto, and it's even more dense than our moon. It has a density closer to the terrestrial planets Mercury, Venus, Earth, and Mars. Io is even more volcanically active than Earth, and it's considered the most volcanically active body in the solar system. It is also believed that Io has either an iron or iron-rich sulfide core. And you might be asking why volcanism occurred on Io. But first, their Voyager 1 revealed plumes shooting up 260 kilometers up into the sky, above the surface. Io has a very, very thin, tenuous atmosphere, and readings subsequently have revealed that these plumes can reach 500 kilometers above the surface. Jupiter's immense gravity produces strong tidal forces on Io. And due to the fact Io is very close to the Jupiter and has an eccentric orbit, it's heated internally, and this causes all the volcanism. Unlike on Earth, plate tectonic activity does not cause Io's volcanoes. And here is an actual photograph of a volcanic eruption on Io. It was taken from the Galileo probe in the mid-1990s, and it's an active fissure eruption at a chain of giant calderas. Here is a picture of Ganymede. Now, Ganymede is the largest moon in the solar system. It has a diameter that is larger than even planet Mercury. It is about 1.1 million kilometers from Jupiter. Thus, it's the third farthest Galilean satellite out there. Only Io and Europa are closer. And also, Ganymede is the only moon known to have a magnetosphere. I did not know that. Some physical characteristics of Ganymede. As you can see, it has a density similar to Callisto. 40% of Ganymede's surface is dark with numerous craters, and the other 60% is light with intricate grooves. And scientists believe these intricate grooves are from tectonic activity or water being released under Ganymede's surface. And later on in the presentation, I'll show you a core and interior of all 4 Galilean satellites. Some Ganymede attributes. It could be easily classified as a planet if it did not orbit Jupiter due to its considerable size. It has a very tenuous atmosphere of oxygen. That's not one of the reasons why it would be classified as a planet. I just wanted to point that out. It's way too thin to support life. And also, I did not know this before doing my research. Scientists believe a saltwater ocean exists about 124 miles underneath Ganymede's surface. The next planet and the next moon, and I find this moon to be the most interesting, is Europa. And later on I'll mention why I find it very interesting. First of all, Europa is the 6th largest moon in the solar system. It has a diameter of 3,138 kilometers, and it's slightly smaller than our moon. To give you an idea, I believe our moon has a diameter of about 3,450 miles. And also, Europa is second closest to Jupiter. Only Io is closer. And what is very exciting is the Galileo probe found evidence of a liquid ocean underneath Europa's frozen surface in 1995. Europa, which has a frozen surface of water ice, is considered one of the smoothest objects in the solar system. It has few craters due to the fact its surface is young and tectonically active. Europa has a vast ocean, perhaps 96 kilometers deep, and it's beneath 3 sheets of ice. And as you can see, it has a density that's greater than Callisto and Ganymede and less than Io. And it is also believed that Europa has an iron core. Here is an artist drawing picturing Europa's ocean. And you might ask, why does Europa have a liquid ocean? Tidal forces from Jupiter and its sister moon, Io, heat Europa's interior. This heating causes water to remain in a liquid state beneath Europa's icy surface. Also, and I found this astonishing, Europa's ocean is thought to contain twice the volume of Earth's oceans. And scientists speculate that due to liquid water, it's possible Europa could support life. First of all, the frozen ice surface would serve as a shield of deadly radiation. And like on Earth, life could exist near hydrothermal vents on Europa. And here is a picture I found online. This is where life may exist on Europa. As you can see, there's a radiation danger of 10 centimeters. And I thought it would be much thicker than that. But then after that, you see the possible life zones. And also on Earth, life can exist without sunlight at the ocean bottom. As mentioned earlier, there's life existing at hydrothermal vents. Now, there has been talk about doing a mission to Europa, drilling into the surface, and thus penetrating into the ocean and searching for life. And this is an artist drawing of a hydrobot searching for life on Europa. I thought this was an interesting photo. My only issue is I hope they're careful not to contaminate the surface or the ocean of Europa. And here is a summary that I found online. It visualizes the sizes of the moon, so it gives you a kind of a visual bearing of the largest moons in the solar system and how they compare to one another. I created this graph myself. It shows the relative distances from Jupiter. As you can see, Callisto is over 4 times farther away from Jupiter than Io is. And finally, here is an interior of the Galilean satellites. It's thought that Io has an iron-rich core. If you notice, it's the only one of the Galilean satellites thought not to have an ocean. Europa is thought to have an iron-rich core with an ocean. Ganymede with an iron-rich core and perhaps probably an ocean. And Callisto is the only one that probably does not have an iron-rich core. Its core is probably made of silicate mantle, ice, and so forth. So finally, here are my references. I hope you enjoyed the presentation, and I appreciate you taking the time to watch it. Thank you. Bye.